Start. We are still in chapter 6, and chapter 6, if you remember, it's about bones. We already went through the first part. We saw the bone cells, the different types of bones, the compact and spongy bone. You saw them already in the lab. I don't think there is any problem with them now. There should not be any problem with them by now, but if there is, please let me know. Okay, you can ask questions, and today we will go through this the second part of this chapter. I believe we maybe touched on the two different types of bones, the membrane and the cartilage bones, but just to remind you of the two types. So if you remember, we said around week 5 or 6, the frame of the skeleton will be laid out in the fetus, right? And we said that frame would be one of two types. The first type would be fibrous membrane, okay, or it will be cartilage, right? So these are the two starting materials, we can say that, for the skeleton. Either we have a fibrous membrane, and we said this is like fibrous connective tissue, right? Very thick membrane, and also we have the cartilage. Now, with that being said, we said for the fibrous membrane, it's going to develop into the skull bones, and the clavicles, okay? And for the cartilage, it's going to develop everything else. So all the other bones of the body, all the remaining bones of the body are coming from cartilage starting material, right? We said based on that we have two different types of ossification. We said, if you remember, we said ossification is making the bone. This is the process of turning that soft materials, either this one or this one, into bones. That's a process we called it ossification. So for the fibrous membrane, we have, this is done through a process called intramembranous ossification, whereas the cartilage is turned to bone through a process called endochondral ossification. Okay, so these are the two processes, either the fibrous membrane, the starting material is the fibrous membrane, and it will turn into bone through intramembranous ossification, or we have a starting material that is cartilage, and it's turning to bone through endochondral ossification. Also keep in mind that the result of the bones, either it will be the skull bones and the clavicle, or everything else in the body. So these are basically the two ways of bone formation and development. So let's see now one of the two ways, the intramembranous ossification. And for this, what's happening, remember that the bones are result from mesenchymal cells. Okay, these mesenchymal cells, if you remember, and I believe we talked about this also in the lab, that all of the in the lecture, all of the connective tissue are coming from what? From embryonic stem cells, right? These embryonic stem cells here, we are calling them the mesenchymal or the mesenchymal stem cells or cells. some of these cells will turn, as we saw in the bone cells, they will turn into osteogenic cells, and these osteogenic cells will turn into osteoblast. Osteoblast, we know that it's producing osteoid, and that osteoid will turn into bone if there is calcium around, right? This is the process. We already saw it in the bone cells. That is exactly what's happening in the intramembranous ossification. So we have some mesenchymal cells. They're already turned into osteogenic cells, which are not shown here. Then they are turned into osteoblasts. These are the osteoblast cells, and they are producing this osteoid. These little dots are the osteoid. Okay, so we have here what we can call it, the place where these cells are located is an ossification center. Okay, so in an ossification center, we have some osteoblast producing osteoid. Now, osteoid, if there is calcium around it, it will turn the osteoid into bone. And remember, when the osteoid is turned to bone, we talked about this already. When the osteoid is turned to bone, osteoblast will turn into what? They will turn into osteocytes, right? And that's what's going to happen here. As you can see now, here now we have osteocytes. Remember, the osteocytes, they have these extensions for communication. These are called the canaliculi, as you can remember, right? But now this area, it's not osteoid anymore. This is hard bone. Okay, this is hard bone, a new bone matrix. So these two steps will keep happening and expanding. So these cells, these are, all of them are osteoblast cells. They are producing osteoid, okay, and in the area around them. And once there is calcium, they will turn into new osteocytes. And this ossification center will expand and keep expanding and keep expanding. Every time there is a new layers of osteoblast cells, these cells will turn into osteocytes once the osteoid around them is calcified, and so on. So this would keep expanding, expanding, expanding in different directions till we have the desired, or till we have like the desired thickness. We can say that. Till we have the desired thickness. Now, before going further into this, I want to talk about these blood vessels. So what's happening that these blood vessels, the blood is always coming to here, coming to this area. Okay, so the blood vessels are coming around, okay? And these blood vessels are, like, their pathway is very random, right? So what's happening is, with these blood vessels, with their random pathway, the osteoblasts are producing osteoid around them. So if you have the blood vessel running around, you will have the osteoid, you will have the osteoblast producing osteoid and turning the osteoid into bone around the blood vessel. So they are not going to say, no, I want to put some osteoid here, or so the blood vessel has to change its way. No, they are laying the osteoid around the blood vessels, which will give this spongy shape for this part of the bone. Okay? That is how this spongy shape of the bone is formed, because the osteoblasts are putting osteoid around the blood vessels. So they are not forcing the blood vessels to change their way. Okay? It's in fact that the blood vessels are forcing the osteoblasts and the osteoid to be secreted in a certain way, rather than to change the pathway of the blood vessel. So this is why we develop a spongy bone in the center. Why again? Because osteoblasts are producing the osteoid around the blood vessels, letting the blood vessels running through what will be a network of these little canals of bones. So this process will continue till we have the desired thickness of the bone. Then the osteoblast would add a layer of compact bone at the surface and the bottom of this bone. Remember the skull bone? We saw the surface is flat. We understand that all of the surfaces of all bones are made out of compact bone, but in the center we will have the spongy bone. That's it. This is the situation we have here. The spongy bone will be sealed by a layer of compact bone, and this process will keep developing, allowing the skull to expand its size to accommodate the increasing size of the brain. That's why this fibrous membrane is very important in here and helping in developing the skull, because if it was cartilage, then we will have limited capacity of these bones. But since it's a fibrous, we always can, these mesenchymal cells can always add these collagen fibers and the fibrous connective tissue, and later that will be used to expand the size of the skull. Okay, so I will stop here, take a pause, and try to answer the question that will pop up. Okay, and then we can resume after this.